Okay, now the last curve that we're going to look at is the graph of y equals tan theta. So if you go to your calculator and you do tan 0, you get 0. But if you do, and here's tan 10, 20, etc., all those results I've already done for you. But notice that this curve is not between 1 and -1, it's actually going quite high. So for example, tan 80, which might be here, is about 5.67. No, tan 30 here is about 0.58. Notice I don't have tan 45, but we know from our exact values that tan 45 is 1. So exactly halfway. So where I'm marking here, that's actually tan 45 and it's 1. Okay. Now if you do tan 90 on your calculator, you get undefined. Undefined. I'm just going to put UNDEF. Okay. So it's undefined. Now, how we represent that on the graph is not continuous. So y equals tan x is not a continuous graph like y equals sine theta, or y equals cos theta. There are gaps. And so here, because it's undefined, if you go tan 90 on your calculator, it's undefined, we have what's called an asymptote, a dotted line. So for example, if I did tan 89, which is just before tan 90, I'd get a really high value. So this graph, I could put arrows here on the ends, it just approaches, this graph approaches this dotted line, but it will never touch it, okay? So actually, if you do take your calculator out, and if I do tan of 89, I get 57 point something. So notice this graph is only going up to 5, so tan 89 is 57, so it becomes very close to the line. Then, for example, if you do tan here, the next one's tan 100 is negative 5.67, which is down here somewhere, okay? But if I say do tan 91, I should get a very big negative value, and I do, I get negative 57. So this graph, when it's very close to 90, so when it was tan 89, it was, I think, 57, for example. When it was tan 91, it was negative 57. So this 90 degrees, this line here is called an asymptote. Okay, and so is this one at 270 as well, at 270 degrees. It's also called an asymptote. So tan 0 is 0. If we look at tan 180, and if you do that on your calculator, tan 180, you also get 0. Okay, tan 270, if you do that on your calculator, you get undefined. Let's just look at this top row up to 180 and the bottom row down here. So from 0 to 180, we've got all those figures. And from 180 or 190 onwards, it seems to be identical to the row above. If you look at the graph, it looks like the curve goes from, this is negative 90 here, so negative 90 to 90, negative 90 to 0 is 90 degrees and another 90. Looks like the period of the curve is 180 degrees, not 360 degrees like the sine curve and the cos curve, okay? So the graph, see, from here 90 to 270, that is 270, sorry, it's 180 degrees from there to there. So this curve repeats every 180 degrees, not every 360. And over here, if I do tan of 360 as well, I get 0. So let's have a look at the quadrants. Here is quadrant 1, tan theta is positive. Quadrant 2, tan theta is negative. Quadrant 3, tan theta is positive. Quadrant 4, tan theta is negative. So therefore, tan theta is positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4. Okay, so remembering our exact values before, we can't see this one on the curve, but we know that tan of 45 degrees is 1. So halfway between 0 and 90 is 45 degrees, and halfway between 180 and 270 is 130. Sorry, no, it's not. It's actually 225 degrees, okay? Because it's actually 180 plus 45. So here, if I look at halfway between 180 and 270, well, that distance, the number of degrees between there and there is 90. Half of that's 45. 180 and 45 is 225. So tan theta is 1 down here. So solving the following, tan theta is 1. There are two solutions, 45 degrees, because here's 1, and 225 degrees. So tan theta is 1. If tan theta is 1, then theta is 45 degrees and 225 degrees. Now we know that tan 45 is quadrant 1. Sorry, there's a mistake here. This should be 225 degrees. Okay? And here tan theta is 1 at 225. Now 225 is between 180 and 270, which is quadrant 3. Remember, quadrant 3 is 180 plus, so 180 plus 45 gives me 225. So tan of 225 is also 1. Remember, these are degrees. Okay? Now, when does tan theta equal negative 1? So here's my negative 1 down here. Seem to be exactly halfway between 90 and 180. That would be at 135. And here, negative 1, also exactly halfway between 270 and 360, which would be at 315. So, tan theta is negative 1, looking at the graph again, when theta is 135 and 315. Okay, 135 is in quadrant 2, okay, and 315 is in quadrant 4, and that's when tan theta is negative, when the graph is below that axis there. So remember, quadrant, cos of 135 is negative 1, and cos of 315 is also negative 1, but 135 is really 180 minus 45, and 315 is really 360 minus 45. So note that the function is undefined for values of 90 degrees, 270 degrees, etc. Okay, so at 90, 270. It's also undefined at negative 90, negative 90, negative 270 as well. So I'll put those in as well, negative 90, negative 270. So those undefined values repeat every 180 degrees because the curve repeats every 180 degrees. So the graph of tan theta repeats every 180 degrees. That is, we say that the graph of tan theta has a period of 180. Let's look for symmetry. Well, it's not line symmetry, because if it was line symmetry and I put a line there, that would reflect over. It's actually point symmetry because it's got symmetry about the origin, about this point here. So the distance from, say, there to there is the same as that, all right? And I can do that from there to there. That's the same distance there. So it's got point symmetry about the origin, not line symmetry. Okay? Just filling these values in the table. Tan of 0 is 0. Tan of 90 is undefined. Tan of 180 is also 0. Back down here, tan of 190. Tan of 270 is undefined. And tan of 360 is 0. Okay, we can see quadrant 1, from 0 to 90, tan is positive. Quadrant 2, from 90 to 180, tan is negative. Right? Quadrant 3, tan is positive, from 180 to 270. And quadrant 4, from 270 to 360, tan is negative. So let's look at quadrant 2. Remember, quadrant 2 is, remember our angles start from 0 there, and quadrant 2 would be like this. So for example, tan of 100. So if this is 100, remember we're worried, we want to know what this angle in here is. That would be tan 80, like it would be 80. But remember, tan is negative in quadrant 2, so it's negative tan 80. This is 110. The related, we call it the related acute angle in here is 70. But remember, tan's negative in quadrant 2, so it's negative tan 70. Just continuing. Tan of 120, if that's 120, this is 60. So tan of 120 equals negative tan 60, just coming up and having a look. Tan of 120 is negative 1.73. That is the same as negative of tan 60, which is negative and then 1.73. Tan of 140 will be negative tan 40, because if that's 140, that bit there, the related acute angle is 40. tan of 150, if that's 150, this is 30. So tan of 150 is negative tan 30. And tan of 170 is negative, that's 170, that would be 10, it would be negative tan 10. Now, quadrant 3 is going all the way around there, where this little angle in there is acute. So we can see that quadrant 3 is 180 plus theta. So, but tan in quadrant 3 is positive. So tan of 190, that's 180 plus 10. So that equals tan 10. And you can have a look. Tan of 10 is 0.18, and so is tan of 190. Tan of 20, for example, is 0.36, and so is tan of 200. So next one, tan of 210, that would be 180 plus 30. So tan of 210 equals tan 30. Tan of 220, 220 is 180 plus 40. So tan of 220 equals tan of 40. Tan of 230, that's 180 plus 50. That equals tan 50. 240 is 180 and 60. So tan of 240 equals tan 60. And we'll, okay, just having a look, tan 60. 1.73 equals tan 240, 1.73. The last one, tan of 260. 260 is 180 plus another 80. Tan of 260 equals tan 80. So in these questions, we're writing any obtuse angles, for example, up here, or any tan of any reflex angles as acute angles. Okay, and the last one, quadrant 4, which is down here. So if you've got an angle coming around there, we need to know what this angle here is. Now, remembering that tan is negative in quadrant 4 from our graphs, okay? So tan, and you can even see it in the table up here, tan is negative. Quadrant 4 is from 270 to 360, tan is negative. So 280, if I go 280 around here, there would still be 80 degrees left there. As tan is negative in quadrant 4, tan of 280 equals negative tan of 80. Tan of 300, if I go 300 degrees around, 60 left. Okay, tan of 300 equals negative tan 60. 320 would leave me 40. Tan of 320 equals negative tan 40. The last three, tan of 330, 330 there, 30 left there, is negative tan 30. Tan of 340, 340 here, 20 left there, equals negative tan 20. And if this is 350 around there, we've got 10 degrees short. So tan of 350 equals negative tan of 10 degrees. So what we're going to do here now is a quick overview of everything and what you need to remember. So what we have, and some of you may have already seen it, you need to know your quadrants. So this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, what we learn is something called all stations to central. In other words, all means, this means that sine theta, cos theta, and tan theta are positive. So I'm just going to go greater than 0, greater than 0, greater than 0. That they are all positive. That's what the A means, all. So ASTC is all stations to central. A means that they are all positive. S means that sine theta is positive, meaning that cos theta is negative and tan theta is also negative. That's what your S means. That only, it means that sine theta is positive in quadrant 2. T, all stations to central. T means that tan theta is positive, and so therefore cos theta would be negative and sine theta would also be negative. So the T means that tan theta is positive. And if it's positive, then the others are negative, okay? So I'll just write this a little bit over here. So that's quadrant 3. And the last one, quadrant 4. Sorry, I'll just make some room here. Quadrant 4, central, C. meaning that cos theta is the only positive one. So cos theta is greater than 0, meaning that sine theta is negative and tan theta is negative. So the C for central means that cos theta is the only positive one. That's what it means. So I'm going to outline, underline or circle the positive ones. The C means cos theta is positive. T means that tan theta is positive. Here, this S means that sine theta is positive. And A means that they're all positive. Okay, so that's what your ASTC, which is all stations to central. Make sure you spell central with a C and not with an S. It is central station, okay? So all stations to central. And you have to go quadrant 1, quadrant 2, quadrant 3, quadrant 4, anti-clockwise. So the way this works, for example, I might ask you to evaluate, or express cos of 150 as an acute angle. So cos of 150. So we look at that and we say 150 would be here. If that's 0, that's 150. This little angle in here is 30. So that's going to equal cos 30, but is it going to be positive or negative cos 30? So quadrant 2, only sine is positive, so therefore it's negative cos 30, because cos is negative in quadrant 2. Another example, I might ask you about tan of, I'd ask you about tan of 240 degrees. So we do a quick sketch. You should always do a quick sketch. Where's 240? I've got 90, 180. 240 would be here if this is 60. So yes, it's going to be the same as the tan of 60, but is it going to be positive or negative? All stations to central, so all stations to central, meaning that tan is positive. So it is going to be a positive tan 60 here. If I go all stations to central, well, only sine is positive here, not cos. So that's why I had negative cos 30. And I'll do one in quadrant 4. I'll go sine of, say, 320 degrees. So I'll do a quick sketch of where 320 would be. Remember, you've got to start from the correct spot. 0's there. I go 90, 180, 270. It'll be 360 all the way around. So I stop short. And if that's 320, then this bit just here is 40. So sine of 320 is going to either equal positive sine 40 or negative sine 40. So let's have a look. We've got all stations to central. The central means that only cos is positive in quadrant 4, so it's negative sine 40 degrees. Okay, and that's how you do those. All right.